Okay, here is the HRW lesson 11.1. I'm going to work out the 8 problems based on the numbers that I have here. Your numbers will be slightly different, most likely in some cases, but at least follow through here, understand what's going on in each question, what's being asked, and how to solve it, and then apply that information to solving for your own numbers. So let's begin. The students in a class were asked which hand they preferred to use for writing. The bar graph below shows the results. So on the left hand we have 8, on the right hand we have 24, and no preference we have 1. So let's look at the question. Of the students who had a preference, what percent chose the left hand? So we have left, we have 8, right, we have 24. So total, we have 8 and 4 is 12, so 32. Okay, so we have 32 total. And they're asking what percent are left hand, so percent left is going to equal 8 over 32. And we want to do that in percent. So first things we will do is turn it on, clear. 8 divided by 32, sorry, 8 divided by 32, better, is 0.25, 0.25. Now percent would be times 100%. So the answer is going to be 25%. Okay, so then the answer here would be 25%. So the first thing you needed to do is get the total number of points, 32, find the fraction of left over total, and that will be in decimal, then convert it to percent by multiplying that by 100. All right, let's go on to number 2. When solving proportions based on data from graphs, why do you often convert from fractions and percents to decimals? And I'm not sure here what it's going to ask for, but most likely it is easier to work with decimals. In many, many cases, as soon as things get large, decimals are easier to work with. I don't know if that's going to be one of the solutions. Hopefully it is. All right, now we're looking at number 3. The number of computers sold in an electronics store each day of the week is shown in the dot plot below. So Monday through Tuesday, Wednesday. Okay. Now, what percent of the computers, we're going to do a lot of adding here. What percent of computers sold on the weekend were sold on Saturday? So we only look at these two for the first question, and we notice that they are identical. So an equal number was sold on Saturday and Sunday, so half of them, or 50%, were sold on Saturday, between Saturday and Sunday. Now, the second question, what percent of the computers sold Monday through Friday were sold on Friday? So here we need to do some math. Monday we sold 2, 4, 6, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Tuesday we sold 1, 2, 3, 4, 5, 6. Wednesday was 5. Thursday, 1, 2, 3, 4, 5, 6, 7, 8. And Friday, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So we need to get a percent, we need a total first. So 9 plus 6 is 15. Let's just do it here. 9 plus 6 plus 5 plus 8 plus 12. That equals 40. Okay, that's looking good on the screen. All right, so on the work week, we had a total of 40 sold. On Friday, we had 12. So we're going to see percent. Percent on Friday is going to be 12 over 40 in fraction, and then multiply that by 100%. So let's do that. 12 divided by 40 is 0.3. Multiply that by 100, and we get 30%. So we'll come down here and write down 30%. The percent of computers sold on the weekend that were sold on Friday is blank, the percent of all computers sold Monday through Friday. So let's see, the percent here was 50%, so that is greater than the percent of any one day during the week. Okay, so the key points here again is you're going to take a percent, so you need a total, then you need a fraction, that'll give you a decimal, multiply by 100, and you will get the percent of the population on a certain day. Moving on, we now have a bar graph with the number of states in the United States primarily in one of the time zones. So let's just, for me, I'm going to go look at it, I'm going to read it, I'm going to write down some numbers. So Pacific time zone, that's 4. I'm going to put it where I can see it. Mountain time zone looks like 7. Hawaii is 1. And then Eastern, 12, 21. And then Central is 16. And Alaska is 1. So hopefully, let's just check that out. We should have 48. 4 plus 7 plus 1 plus 21 plus 16 plus 1. We actually should have 50, and we do. Now, we're talking about, the question is talking about continental United States, so we don't count Alaska and we don't count Hawaii. So what percent of the states are primarily in the Eastern time zone? So we know that continental United States, there's a total is 48. 48 states minus Hawaii and Alaska. Now, on Eastern, we had 21. So we have to get the percent would be 21 over 48 times 100%. All right, so let's do that math. Get it out here where you can see it. Not too shiny. 21 divided by 48 equals 4375 times 100, and we get 43.75%. So the percent of states in the Eastern time zone is 43.75. Okay, that would be 43.75. If yours asks for a different time zone, you would simply use that number in the numerator to get the answer. Okay, we've got the same bar chart. Let's see what we're looking for this time. The number of states is shown in the bar graph, same as before. I'm going to go ahead and redo 4 here, 7 in the mountain, 1 here, 21 Eastern, 16 Central, and 1 in Alaska. Suppose the horizontal scale of the bar had intervals of 1 instead of 4. So instead of 1, we do 2, 3, like that. So you see all of those. And would there be advantages or disadvantages? Well, let's think about it. I had a little rough time with making sure this mountain had 7. Reading that one was a little bit chart. So it would make it easier to read, but the rules would be so close together it might make it more difficult. I don't know if these are proper, but think about it. If you have, the finer the grading, the easier it is to tell where the bar ends. But if it gets too fine, you can't see. If I try to put 1, 2, 3, it would still be just as messy down here. So it's easier to read in one respect in that you can be more precise on where the number is. But as you get finer and finer details on the X direction, it gets harder to read because it's just so close together. So let's see if those answers will work for you. Moving on to pie charts, or sorry, circle graphs. We'll always call them pie charts. All the boys were wearing tuxedos. The circle graph below shows the number of boys wearing each of the different bow ties. Now, these are the number of kids, boys, but now we need percent. And remember, the circle represents 100%. So we need to first find out how many in the total. So we have 66, 25, 46, 23, 20, 13, and 7. All right, so let's add those together. 66 plus 25 plus 46 plus 23 plus 20 plus 13 plus 7. Now remember, your numbers might be different in your particular problem on HRW than this one. Okay, so we now know that there's a total of 200. So let's see, what's the percent of yellow? So yellow will be 66 over 200 times 100%. All right, so let's do 66 divided by 200, and we get 0.33. 0.33 times 100 equals 33%. All right, so let's go with gray is 25. 25 over 200, and then we multiply that by 100% to get that into percent form. 25 divided by 200 equals 0.125 times 100 equals 12.5%, 12.5%. All right, so that was gray, and we'll put 12.5. White equals 46 over 200. 46 divided by 200 is going to be, or times 100%. So that equals 0.23 times 100 equals 23%. All right, moving on. Just write that down, 23%. Now we're going to red, so I'm going to slide up a little bit. Red equals 20 over 200 times 100%. Okay, I can do that one in my head. Hopefully you can as well, but 20 divided by 200 is going to be 0.1 equals 10%. Okay, green. Now this is a different, so this is going to use green, GR. 13 over 200 times 100%. 13 divided by 200, that's 0.065 times 100, 6.5%. And now we're off to, oh, sorry, that was, oh, I'm sorry. So green is 6.5, red is 10%, and I missed dark blue. So dark blue is 23. Make sure you don't have the same mistakes I do. 23 divided by 200 is 0.115 times 100 equals 11.5%. All right, so got to make sure I do things well. 11.5. Next is light blue, last one. 7 over 200 times 100%. 7 divided by 200 is 0.035 times 100, and we're up to 3.5%. All right. Okay, so you see that first thing we did was we had to get the total for all of them, and that's 100%. So all of them together, 200 boys, 200 people makes 100%, and in each case now we take the fraction of the pie slice and divide it by the total, and we get our percents. In number 7, we see a dot plot that represents the number of pizzas sold at a local restaurant. So we're saying number of pizzas sold at a restaurant each day in 1 week. One row of dots on the plot is much taller than the others. So what does that mean? Complete the explanation of what that means in the context of the data and the percents. Then complete the explanation. So here you're going to look at the drop downs, and I don't have them on memory, so let's talk about it. If a row of dots is much taller than the other, that means they, in one way or another, sold more pizzas that day, or most. On a circle graph, the area would be noticeable because it would be, well, let's see, big circle, 1, 2, 3, 4, 5, 6, 7. Obviously, this is the big day because it is the largest section. Those are my words. It might be different on the HRW, but the concept is the same. If it's on a dot, it would be the something like this, where the dot would be the biggest one, and if you did the same data on a circle, it would be the biggest piece of the pie. Last one. What is the relationship between the degree measure of an angle formed by the straight edges of a section of a circle graph and the percent of the data that's set? Well, let's look at that. That sounds confusing to me. I'm going to draw my circle graph. All right, and so we always have our circle, so we have a center in the middle. And if the degree measure is a straight edge, so if this is it, what do you think it is? The percent is equal to the degree measure divided by the whole. And then, let's see, by the total. And then multiplied by 1. Okay, so I understand now what it says. So it could be a straight edge there, but it could be this angle, for instance. So we know that in a circle has how many degrees? 360 degrees. If this one was something like 30 degrees out of that, then we could find out the portion by doing the same thing we were doing before, 30 over 360. As an example only, 30 divided by 360, backspace, clear, 30 divided by 360, and that one represents 8.3% of the pie. So depending on how these drop downs look for you, what they're asking for is how do you find a percent when you're given angles. And then you have angles being, 30 degrees. And it would be the same as you would when you were doing quantities. So that concludes the 8 problems as they are in my download from HRW. For you, the numbers will be different, but the concept should be almost identical and the process would be the same.